The discovery of atomic structure involved multiple key experiments and scientists, each contributing critical pieces to our modern understanding. J.J. Thomson's discovery of the electron, 1897, through his cathode ray experiment. Thomson demonstrated that cathode rays consisted of negatively charged particles 1,000 times lighter than hydrogen atoms. Using a partially evacuated glass tube with electrodes, he identified these particles, originally termed corpuscles, which were later named electrons. This was significant as it proved atoms were divisible and contained subatomic particles. Rutherford's nuclear model, 1911. By conducting the alpha scattering experiment, Rutherford fired alpha particles at gold foil, discovering that most particles passed through, indicating substantial empty space in atoms. However, some deflections suggested a dense, positively charged nucleus at the center of the atom. This experiment disproved Thomson's plum pudding model, instead proposing a nucleus around which electrons orbit far away. Niels Bohr's atomic orbits, 1913. Building on Rutherford's model, Bohr suggested that electrons occupy fixed energy levels or orbits around the nucleus. He proposed that energy quanta are absorbed or emitted when electrons jump between these orbits, thus explaining hydrogen's spectral lines. Though a breakthrough, later quantum mechanics revealed that electrons exist in probability clouds rather than defined orbits. Discovery of the proton, 1917 to 1920. Rutherford furthered his nuclear theory by observing hydrogen nuclei, protons, emitted during the bombardment of nitrogen with alpha particles. He concluded these protons resided in the nucleus to balance the negative charge of electrons, explaining the atom's overall neutrality. Clarifying misconceptions. The alpha scattering experiment's primary revelation was the nucleus, not electron orbits. Bohr's separate work clarified spectra through defined orbits. Rutherford's identification of the proton resolved the challenge of atomic neutrality despite the presence of negatively charged electrons. This progression, from Thomson's identification of electrons to Bohr's theoretical orbits, illustrates how atomic theory was painstakingly refined through focused experimentation and thoughtful model evolution.